Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on the year-end summative. It's question 11, which is from the quadratic relations section.
It says, a rectangular swimming pool measuring 10 by 4 is surrounded by a deck of uniform width. The total area of the pool and deck is 135 square meters. What is the width of the deck? Okay, so here's that kind of diagram that they gave us. So we know that the pool is 10 by 4. We know that the total area is 135 square meters. And we're supposed to find the width of the deck. So we're told that this deck is the same width here and here and here and here. So it's a uniform width. So no matter where you measure the width of it, it's the same. So what is that width? Well, I don't know. And in math, when you say I don't know, you write x. So the width of the deck is going to be called x. Right? Because we don't know it, and we need to figure out what it is. So let's clean up this picture a little bit and see what we can do about turning this into some sort of equation. So first of all, you should start by saying let the deck width be x. Okay. Now, the only information that we have to help us create an equation is the size of the original smaller pool, so the blue, and the fact that the total area, here's the total area. So this rectangle here, which I'm, shading in, sort of, that has an area of 135 square meters. So, now, this thing that has an area of 135 square meters is a rectangle. And how do you find the area of a rectangle? So its area is length times width. So if we can figure out what the length and width are, we can set up an equation. Okay, so let's get back to my original diagram. So here's the length of this deck. It goes from here all the way over to here. So what is that distance? What is that measurement? Well, we know that this distance here for the pool is 10. And then we have this much more plus this much more. And that is the width of the deck. So this is x and this is x. So therefore, the length is equal to 10 plus 2x. That's the length of this whole rectangle. So now let's do the width of the rectangle. And again, the width goes from here all the way down to here. So the first chunk is this piece here. That's the pool. And that we know is 4 meters. And then there's this piece more plus this piece more. And again, this piece is the width of the deck. And this piece is the width of the deck. So that means that the width is 4 plus 2x. So I have a representation of the length involving x, and a representation of the width also involving x. And we know that length times width is area. So let's go to the next page, and we'll write that neater and algebraically. So again, area is length times width. And we know that the area is 135, and we just found that the length was 10 plus 2x, and we found that the width was 4 plus 2x. So there's an equation, and all I have to do now is solve for x. So how are we going to do that? Well, solving for x, this is, at some point, I'm going to be multiplying x times x. So this is obviously a quadratic, but it's not in factored form because it doesn't equal 0, and it's not really in any great form. So we're going to have to do some math on it before we continue. So I'm going to multiply these brackets together. So 10 times 4 is 40. 10 times 2x is 20x. 2x times 4 is 8x. And 2x times 2x is 4x squared. So let's bring 135 over and rearrange. So I'm going to have 4x squared. Here, that's going to be plus 28x. 40, subtract 135, is going to be minus 95. So hold on, I wrote that wrong. 40 minus 135 is negative 95. So here it is. So now I have a quadratic equation that looks more like a quadratic equation that we were used to. So there it is. So how do I solve for x? Well, there's no point in completing the square because I'm not interested in any sort of maximum or minimum. So that means I'm either going to factor it, and I'm not in the mood because I don't know. Usually for me, if it looks like it's going to take me too long to factor, I don't bother. And that means the way to solve for x is we're going to use a quadratic equation. So let's take this equation and we'll go to a nice, neat page. Took the green box. There's my equation. Nope. There it is. Okay, so we're going to take this to the next page. It's easier when you have like one piece of paper, so you can just look up on the paper. But when I'm switching pages on this program, then I have to keep track of what I'm doing. Okay, it didn't work. I'm just going to remember it and rewrite it. So we have the formula 0 equals 4x squared plus 28x minus 95. And we're going to solve by using the quadratic equation. So I know you have it memorized, but here it is just in case. So a equals 4, b equals 28, and c equals negative 95. Okay, so substituting into the equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that to me is the first step of using quadratic equation. And now I can actually figure out what my substitutions are. So negative b and b squared, so b is 28. So minus 4ac, and this is over 2a. So there's my substitution, and now I'm just going to do the math. So x equals negative 28, and obviously the part that's under the square root is really important that you're being careful. So 28 squared is 784. And then here I have minus 4 times 4 times 95. Well, two negatives is going to make this positive. And then I'm just going to do in my calculator 4 times 95. And that's positive 1,568. And this is going to be over 2 times 4 is 8. So x equals negative 28 plus or minus. So add 784. So the square root of 2352 over 8. And now find that square root. So when I take the square root, I'm not going to worry about whether or not to use decimals. I mean, it's a word problem. You use decimals in word problems unless something major says not to. So there we go. The square root of 2352 is just about 48.5. So at this point, the only thing left to do is to take the plus and minus and separate into two different answers. So I'll put one answer over here, and I'll put one answer over here. So we have x equals negative 28 plus 48.5 divided by 8, and x equals negative 28 minus 48.5 divided by 8. Okay, so in your calculator, what do we get? So negative 28 plus 48.5 divided by 8. So I get 2.56 as one answer. And then the other answer for x is negative 9.56. Now, does a negative answer make sense in this question? So remember, we're finding the width of a walkway. Well, obviously you don't measure widths as negative numbers. So this one here, oops. So I will make sure that my teacher knows that this is number. I cross it off and I write this fancy word, inadmissible, meaning that it is a valid root of the equation, but it's inadmissible, not allowed, as an answer to the original question. So this must be the answer. So therefore, the width of the walkway is 2.56 meters. Okay? So after we had set up the equation, this is a fairly straightforward question, just using the quadratic equation. Just make sure that you know how to set up these equations. It's a pretty classic question to talk about something that has a uniform width like this. So don't forget, the key is to choose your variable properly and set up your equation right. So I hope that helps. If not, post in the comments, come see anyone in the math department, etc. Good luck studying. That's it.